12.6 is on cylinders and quadratic surfaces. So first we're going to define what we mean by a cylinder in general. So we know you think of a cylinder like this, right? This is what we look at it as a cylinder. And that is a cylinder the way this is defined, but the way we look at it, there's other forms that we consider as cylinders. So this is going to be an interesting section because it's hard to show three-dimensional things without physically describing it like I would in class with showing you objects in my hands and stuff. But we'll get through it, and I will use the computer 3D grapher to show you stuff as well in this video. So cylinder, some of you who've had me, I bring in that water thing I always drink, and that's what I always show is the basic concept of a cylinder. But there's other ways to describe it. That's more a general concept. So write all this down. The definition of a cylinder, we're going to let C be a curve in a plane. Okay, so that's just going to be some curve like that. And let L be a line that is not in a parallel plane. Okay, so write that down, not in a parallel plane. So you have a curve, basically, and then you have these lines that essentially connect it. And I got a picture I'll show you, like that. The set of all lines that are parallel to L, so you start off with a curve and then a line, call that L. So it's the set of all lines parallel to that. So it's all of these, the ones I just basically drew. And intersect C is a cylinder. So I have down here that definition. So this is the concept. I drew it good before, so I figured I'd just copy and paste it here. Okay, so that's the general idea of a cylinder. So if you start off with, say, this curve like this, and then you have like this as your line, maybe that's your L. Then it's all of these other lines, all of them, right? So you create this sheet of like whatever, of a surface, and that sheet kind of oscillates just like the curve would. Okay, so that's what we mean by a cylinder. So if you draw an actual cylinder, it's the same concept. So sometimes I draw this first. So this is what we normally think of as a cylinder, or at least a right cylinder, is this. But it doesn't even have to be that shape or even like slanted. So this one here's like your line, okay, and then here's your curve. Well, start off with the curve. So here's your curve, would be like a circle, and then so then you used to have a line, and then the set of all lines parallel to it, right? All of these, that creates the cylinder all the way around. So picture like hold up a Coke can or something, and you know that's a cylinder. So the circle on the bottom or top is like your curve. And if you draw like a line next to it, then all of those lines parallel to it that intersects the curve or the circle create this cylinder. Okay. All right, so that's what we look at first. Let's do some more definitions on that. Oops, I should have cut those. So let's get into sketching different cylinders in the general case of a cylinder. So sketch the graph of x squared over 4 plus y squared over 9 equal to 1 in 3D or R3. So what's not stated again, what's not stated precisely is that z is arbitrary in the reals. So you still have a z value that goes anywhere. So let's to sketch these, and we're going to get into sketching more and more stuff. So this is kind of the general way of sketching and doing things. And what you can do is sketch in whatever variables those are. So if that's x and y, so you do it in 2D first. So let's sketch that in 2 dimensions first. So in 2D, what would that be? Okay, and that would be an ellipse, right? So you have an ellipse, and you have underneath the x variable is 2 squared and 3 squared. So we're going to do along the x-axis 1, 2, 1, 2, and the y would be 3, like that. And then this will often actually draw an ellipse. Let's see if it does it. Yeah, so it did it pretty good. It's just a little off, but that's okay. You can sometimes twist these to make them work. Okay, pretty good. So that's your ellipse that you get in 2D. So in 3D, you have a line that basically, your z-axis is basically coming out of, however you're looking at this, coming out of the screen, essentially, is your z-axis. So that creates that cylinder. So you can draw this in 3D like this. At least that's your attempt, right? And so this, this is kind of hard to draw. You just label it, and that's what it's going to be. So you draw in your ellipse, and actually, I think if I do this right, I can actually copy that and then paste it down here, and then like twist it so it'll be like a cylinder or an ellipse on there. Kind of like that. It looks a little better. And then you can go in and label things. So this would be, this is your x, this is your y, and your z. And so that would be 2 out on your x, and then this would be 3. And it doesn't have to be perfect. It's just kind of what it looks like. And then you basically go up on the side. So it goes up and down like this. It's close enough. And then, let's try it again. So you go like this, and then you draw on your cylinder like that. And it's just a rough sketch. Sometimes you can come in and make these dotted in the back so it looks a little better, because it's kind of looking through it to the other side like that. And of course, it does go down as well and up infinitely, so it doesn't really stop. Okay, so that's a cylinder. Okay, so we're going to just draw a few of these different things for now. Okay, I'm going to go and erase these. Okay, so next examples, try this one. This is same question. I'll just do like A, B. So A, this one is y squared equal to 9 minus z. And then you'll try B as well. Z equal to sine x. So this is where I usually have you kind of try it on your own. It's not enough to really get in groups at this point, but try it on your own, see what you can come up with. And I usually show you that you can write z as equal to negative y squared plus 9. So that's basically, graph that in the zy plane, which is kind of in the back. It's not on the bottom, it's in the back, the zy plane. So what would that be in the zy plane? And you can do it two ways. You can do do the zy plane just like y equals. So that's kind of like the form y equals negative x squared plus 9. So what would that look like? So if you graph that in this would be y and this would be z. Because that's like a function of y. And so we know that would be up 9 units. So 1, 2, 3. So just, it's just, you're looking at the sketch. So this would be, it would look like this. The parabola opens down in the zy plane. But this is in 3D, right? I wasn't saying that was the right graph. I'm just saying you can do 2D first and then do 3D because isn't your x arbitrary, right? So x in this picture would be coming out of the screen, right? Or paper or whatever we're looking at. So now let's draw that in 3D. So in 3D, well, it's on the paper. So some of you who like to draw or more into art type stuff, you maybe can draw these a lot better. Took me many years to practice how to draw these things, really. Wasn't very good at it at first. So the zy plane is like back here. So it goes like that. That's picturing your zy plane, right? So it's in like that. And then it's going to come out this direction and that direction. So you usually only have to do the positive case. So it's going to come out like that. So in the back, you go up to 9 units. It doesn't have to be exact. Just go up to make it look nice. And that's what your parabola is doing. It's going down like that and down like that. And then it's coming out like this along the x-axis. And then those are kind of dotted in the back. So make those dotted. Okay, not really good of a sketch, but it's reasonable, I suppose. Okay, so that's kind of what it looks like. And then clean it up the best you can. This one maybe can be solid like that. Okay, so can you sort of picture that as that's coming out along the x-axis? Maybe let's change the color on the x-axis. I don't like that color. Let's change it to orange. Okay, so here's your different axes. Make it look like that. And so that's what it's coming out on. The only thing you'd really need to label, if asked, really, is you'd say that's 9 because you're up 9 units. Like that. Okay, that's pretty good. Now what about z equals sine x? So z equals sine x is, again, you can graph it in 2D first to get an idea. So in 2D, that's your curve. And what would it look like? Well, that's like saying this is x and this is z. So it's in the xz plane. So the xz plane is like back here, like that. Okay. In 3D, it's like back here in that picture. So here you have your basic sine curve, which is oscillates between -1 and 1. So if this is 1, this is -1, it would oscillate like that. Right, and it is symmetric and all that stuff. So you draw a little better graph than that maybe. Okay, but that's how it's oscillating. So basically, then it's going to come out along the z plane and get that like wavy pattern. This one's a little more difficult to draw. I think I'll give it a shot here. The picture I drew before looks okay. Should be able to reproduce it. Let's take a look. So you draw on your axes. And you want this to be standard. You don't want to move your axes around because we all want to agree that x is coming on the left. This is y, and then this is z. So you have and this again, this is just a rough sketch. It's gonna come. I'll label some points here. This one I actually did go back to make it, and then I erased that, made it dotted. kind of see it a little better maybe. So, oh, and how you make this look better is like you do large and then you make it smaller. And large and then smaller. Kind of makes it look like it's going back. And then you can do down as well. And then make it dotted. Now that dotted should be the same distance apart, although I'm not, we're not too particular about it, but so you get it somewhat, try to do a perspective on that a little bit. All right, so this oscillates, let me do this thing first. So this oscillates like this, and then it comes out, then it comes out like that. Those are your lines. Okay, so it's a wavy sheet like that. And so what we can do is take that, and I don't think that copies yet. And so you have another one out here like this, and like this, and then that's your, that's how it is. Now you can take more time and make it more, look better. But that's essentially how it might look. Yeah, my other one was a little better, but you get the idea how it's wavy like that. Okay, so that's how you do cylinders, and let me go ahead and show you a couple cylinders on the grapher. So this is my 3D grapher, and let's look at this list. I can't point to this, so we'll have to just look at the top, or I'll just describe it and then like the color. So you want to look for z equals something and then a variable missing. So in this case, let's see, where did I have that? So z x y 4 minus y squared, that should be a kind of what we had before, a parabola that opens down. So look at this blue one right there at the top. 4 minus y squared. So write down 4 minus y squared. That should be a parabola that opens down, right, up 4 units, and then but the x variable is missing. So that means it's going to be like a sheet that comes out. It's not going to be like a parabola or anything. And there you go. Okay, so there's that. There's the look of it, and then you can do different. That's like the grid pattern. That's usually the best way to look at it. You can see how it is. There's your parabola. It is in the parabola itself is in the z-y plane, and then it comes out along the x. It's similar to one we just did. Okay, and let's see another one. I see ones that'll work in there. I think that's the only one I have. Here's a let's see. Here's a parabola that opens up, right? And this is z-y plane. That one opens up like that, and there's your sheet or surface that you have. Okay. That's usually the orientation. We look at it, and you can see how it comes up like that. Okay, so let's go ahead and go back. The next thing we'll look at is what are called quadratic surfaces. So probably a good place to stop and go to the next video. So write down quadratic surfaces. We will do those next.